syllabus during the last week. We're gonna make some quick revisions so that you can prepare better for your final exam. Alright, so that's the plan for today. First, let me try to share my slide first. Okay, I think in your Putra Plus, they have blocked you from access your content. I don't know whether this is temporary or permanent, but I don't think it should be permanent because you should access your content, of course, during your study, right? But never mind. If you cannot mark your attendance for today, I will check your attendance during our masa during our photography session nanti lah. Okay, bila kita nak ambil nanti kita akan ambil gambar sikit lah because this is our final class. So let's this one. So okay, first we look at the whole content of our course. Okay, the whole content of our MTH 3100, so that you can have some kind of arrangement lah. Dalam maksudnya you can compartmentalize your brain, some sort of that, so that you can you can build a structure in your mind. What is the whole content of this course or class? Okay. See, your friend said that the Putra Blast is undergoing maintenance process until 12 p.m. So meaning that after 12 p.m, maybe you can access your content for the Putra Blast. Okay. I think I have updated the recording of our class in Google Drive. So I think at the end of this class, or maybe after this, maybe one of you can remind me to put the link in our WhatsApp group, so that during your study week you can access the recording of our class, and then you can do some revision there. Okay, boleh tengok dari situ jugalah. Okay, so that you will have full access of materials that we have covered so far, so that you can be better prepared for the final. Okay, I hope that by doing that you can be fully prepared for the final. Okay, first let's see. Okay, kita tengok balik pada our first chapter. So our first chapter MTH 3100. So the first chapter is about, what is the first chapter? And sorry, my kids here. Okay, the first chapter is about functions. Okay, ingat balik pasal function. Of course, one thing that I can tell you about your final, the one that has been tested in test 1 and test 2 will not be asked again in your final. That one I can tell you lah. But not necessarily chapter 1, 2, 3 and 4, because your test 1 and test 2 are heavily contained in chapter 1, 2, 3 and 4. Okay, so that doesn't necessarily mean that chapter 1 until 4 will not be in the final. Maksudnya ada jugalah content from chapter 1, 2, 3 and 4 in the final, but the one that has not been tested yet. Okay, yang ada dalam final nanti ialah content dalam chapter 1 sampai 4 pun ada, tapi yang tak masuk final lagi. Yang tak masuk test 1 dengan test 2 sebelum ni. Okay, so maybe you can check. Maybe you can cross check the test 1 and test 2 so that you can eliminate some of the contents that has been tested in test 1 and test 2, because that one will not be asked in your final. Okay, maybe that one can save you some time lah. Okay, boleh kurang jimatkan masa kamu sikit, masa kamu nak buat revision lah, and then you can focus on the more important chapters. Okay, then the second, we are talking about limits. Okay, so remember the concept of limit, and then the asymptotic, and the one have been tested in test 1. But why I put this one, not just for your final, okay, bukan sekadar untuk kamu punya final. So apa saya beritahu ni, the whole content of this course ni, sebab saya beritahu, sebab so that you can know what you have learned so far in calculus. Okay, of course, going further after this, you will learn more about calculus. I don't know, is this the only mathematics course that you will that you have to take? Ini je ke matematik subjek yang kamu kena ambil? Saya tak pasti. Someone maybe boleh jawab.
We have algebra in Sem1 as well, Doctor.
So algebra. Okay. So after that, other than algebra and calculus, tak ada lah. Itu saja.
Ada what? I'm not sure.
Oh, okay. So mungkin algebra dengan calculus lah. Saya pun tak familiar. Actually, I'm sorry sebab this morning I'm not feeling very well actually. Tapi tak apalah, sebab last class kan, kita teruskan jugalah. So yang ni pasal calculus lah. This one is about calculus, about algebra. It will be of course that one is a mathematics subject, but it will be related in some things, but not related in all of the things that we have covered in calculus. So by showing you this, maybe you can compartmentalize your mind so that you can use the application of calculus in your field. Okay, especially because I think most of you are doing what we call as the natural science. Okay, physics, chemistry, science bahan or whatnot. They are all using mathematics as a tool. Okay, as a tool of measurement, as a tool of identifying something. There are a lot of tools using mathematics. So these are all the tools that we want to introduce to you. Okay, and then we have this one. We have the derivative.
Doctor, sorry to disturb. Ada yang nak masuk.
Oh yeah,
sorry.
Tak perasan. Okay. So and then the application of derivative. And then we also have the antiderivative. And ada apa? Dan ni apa namanya? Transcendental function. And then chapter 7 pasal apa? I rasa we tak cover kan chapter 7 kan? I check back. Chapter 7. Oh, chapter 7 kita cover, sorry. Technique of integration. Okay, chapter 7. Technique of integration. or technique of antiderivative. And then now chapter 8, I think we don't cover it, that. And then chapter 8 is about, yeah, this one. Taylor series, right? Taylor polynomial and Taylor series. Okay, we don't cover that. And finally, partial derivative. Okay. So you can see the progression in our course. For the function, we learn about the function and graph, and then we go into the limit. So maybe this the concept of limit is a new concept for you, because we only in secondary school we only apply the concept of limit without knowing the concept of limit is the machine working behind it. Okay, sebagai contoh, the concept of limit is also used in the derivative. Okay, for example, the concept of limit is also used in the derivative. In the definition of limit is what? In the definition of derivative is what? The definition of derivative is using the concept of limit, but we don't know yet. So we can see the progression from the limit to the derivative, and then we also see how we can apply our derivative, not just in measuring or but to sketch a graph, but we can also use the application of derivative to find or to solve the related rate problem, right? The one that you solve using your SEL task. And then from the derivative, we go to the antiderivative, where in the antiderivative chapter we can see that we can use this concept of antiderivative to compute the area under the curve. Okay, from the Riemann sum application to the infinite integral, and then we can also use finite integral to compute the area under the curve. So they all are the antiderivative. Okay, and then from the antiderivative we go to the transcendental function, where the transcendental function we focus on the natural logarithm and also the exponential function. Okay, where both of these counteract to each other. Okay, dia macam saling dia punya inverse function, right? Sekejap Okay, then from the transcendental function, we are okay in the chapter 6. We also learn about the L'Hopital rule. Okay, L'Hopital rule. So in the L'Hopital rule, this rule actually provide you a technique to find the limit of a function that commonly, or if we use the technique that we use in the limit chapter, we will get undefined answer. Okay, so in the L'Hopital rule, we have seen that this technique can use to solve some, especially the transcendental function lah. Okay, so that we can find the limit of a certain function in certain circumstances. And then in the chapter 7, we will learn about the technique of integration by parts. And then we also learn about the partial fraction, where we can simplify a rational function we can have 4 types of fraction that can make our job to integrate the rational function easier. So that is chapter 7. Okay, chapter 8 we don't cover, but of course, I will be glad if you can read yourself about the Taylor series and the Taylor polynomials, because maybe it can help you during your future research or future in your field lah. Okay, maybe lepas final ke ataupun bila tengah cuti SEM ke, you want to read about the Taylor series, you are very welcome lah to do that. And then finally, we learn about the partial derivative. Of course, if you are a mathematics student, you will use the partial derivative heavily in the advanced calculus. But I'm not sure whether you have to take advanced calculus or not. But I think based on the answer from your friends before, maybe you don't have to take you don't have to take advanced calculus lah. But partial derivative is very important so that you can find the derivative of more than 2 variables, 3 variables, 4 variables, and so on. Okay, so that in your field, if you have if you want to conduct an experiment using more than 2 variables, more than lebih daripada 2 pun boleh ubah, kamu boleh gunakan partial derivative. And you can see that what is the meaning of derivative actually. Okay, apa maksud derivative itu sebenarnya? If we compute a derivative of a function, what does it tell you actually? Okay, first the derivative tell you about the gradient of a tangent line that cross or that intersect with a function, sebagai contoh. And then if you compute the antiderivative, what actually do you get? Okay, what can you get from the antiderivative? For example, you can get the area under the curve. So that one, all of them are very important. Because they are all the tools, they are all the mathematical tools that will help you to conduct your research, your experiment, and not just of course, if you're not working as a researcher in the future pun tak apa, sebab all of these techniques, all of these tools can help you to interpret data. If you are working in the working space where it always involve data. Okay, kalau kamu ada data, certain data, you can use these mathematical tools that we have learned in this course to interpret the data. So that is what we have learned so far in MTH 3100. I have told you before, we have covered chapter 1 and until chapter 4 mostly in our test 1 and test 2, right? However, the one that have not been tested yet in these chapters can or may be in the final. So you must cross check lah, apa yang belum lagi keluar, apa yang belum lagi test dalam test 1 dan test 2 untuk chapter 1 sampai 4, kemungkinan besar akan masuk dalam final. Okay, so this class actually, I just don't want to tell you straight away that what is out in the final, what doesn't come out in the final. I don't want to give you straight away about that. So because I want you to relate all of our knowledge here to your future lah. Okay, itu yang saya cuba buat lah untuk hari ini. Okay, so we will see, we will try to revise some things in the antiderivative, and then in the chapter C also, chapter 7 and chapter 9. Okay, so let's go on. So, okay, this is chapter 5. Okay, chapter 5. I will jump. Saya tak sempat lah untuk kita cover semua. Tapi kita akan jam lah apa ni saya rasa penting, saya akan tunjukkan lah. Okay, for the area under the graph of a function, so if we have a region with the curve boundary, so the area can be approximated by summing the areas of a collection of rectangles. Okay, this is an introductory to the antiderivative concept. Okay, satu permulaan bila kamu nak belajar pasal antiderivative. Okay, bila kita ada satu curve boundary tu, kita cuba dapatkan the area under the curve by using the sum of the areas of a collection of rectangles. Why rectangles? Because it's very easy to compute the area of rectangles. Sebab tu kita pakai segi empat untuk cari the area under the curve. So using more rectangles, okay, so by using more rectangles segi empat, it can increase the accuracy of our approximation. So I hope that I think I already covered it in our class, but I hope that you can imagine how more rectangles can increase the accuracy of the approximation. If you get that intuition that more rectangles can increase the accuracy of the approximation, kalau kamu dapat intuisi tu, kamu boleh nampak how this intuition can be related to the concept of antiderivative later. So this is how we get the region below the graph of a function by using the rectangles. So how to get this area under the curve by using the rectangles? First, you must know the length of the interval here. Okay, so for example, we have 1, 2, 3, 4, 5, 6. We have 6 rectangles here, and then all of these rectangles have the same length in the x-axis. Okay, along the x-axis, they all have the same length. Okay, x1, x2, and if you have x3, same juga x4 until xn. So how we can get this one? How we can get the length of x1 until x2, x2 until x3, x3 until x4? So by using this length of each subinterval. So the length of each subinterval, we call it as a delta x, will be equals to b minus a over n. So for example here, they want to have n as 8. Okay, dia nak ada 8. Of course, the rectangles are only 6, but because the point here can go to 8. Okay, x0 dengan x8 here kat sini. Okay, x0 1 2 3 4 5 6 7 8. Okay, so you can see that x1 and x2 will be, so because this one is point B on x-axis and this one is point A, so B minus A over N, 8. Okay, so for example, if this one is 2 minus 0 over 8, which is 1 over 4. Okay, so this one is 1 over 4, this one is 1 over 4 plus 1 over 4, 1 over 2, and then in this one is 3 over 4, and then this one is 4 over 4 or 1, and so on. Okay. So, meaning that we can compute each one macam yang saya buat tadi lah. Okay. So S1 will be S0 will be A. So S1 will be A plus macam tadi B minus A over N, ataupun tadi saya kira 1 over 4. So 0 plus 1 over 4, 1 over 4. S2 will be S1 plus 1 over 4, which is 1 over 2. And then dan seterusnya. Maksudnya kita akan boleh dapatkan nilai x1, x2 until xn. Okay, kita boleh dapatkan itulah. Okay, and then so the area under the curve will be for the rectangle. Okay, kalau untuk satu rectangle tu, dia punya formula untuk cari the area will be Fmi times B minus A over N. Yang ni kita dah yang ni kita dapatkan lah. So Fmi ni ialah apa? Dia punya minimum of F. Okay, over the x0 until x1. Okay, dia punya minimum. So kita tahu juga pasal summation notation. Okay, in the summation notation, I think the one that is very important for you to know yang macam ni lah, yang mana? Yang ni. Okay, kalau satu, the summation of 1 from 1 until n is n. The summation of I from 1 until n is n times n plus 1 over 2. For I square is n times n plus 1 times 2n plus 1 over 6. And for the I cube will be like this one. Okay. So if you have 3I square. So if you have 3I square, meaning that you must put the 3 in front of here. So dia akan jadi inilah 3. So meaning that every function, every quadratic function, every cubic function, ni cubic kuasa 3, ini quadratic kuasa 2. So every cubic and every quadratic function and every linear function, we can compute using the summation of this one. Okay. So we have to manipulate lah dia punya coefficient, dia punya pemboleh buah depan tu. So sebagai contoh tadi saya kata kalau kita ada 3i square, so we put 3 in front. Maybe kalau if we have 3i square plus 2, 3i square, so 3 here plus 2 belakang, for example. Okay, and we can compute the summation here. So by using this one, okay, by using the knowledge of the summation of the rectangles to compute the area under the curve, we can see what is the Riemann sum. Okay, so the Riemann sum is very important concept for you to relate the concept with the antiderivative. So for the Riemann sum, actually what we have do, what we have done in this lecture 25 is actually the concept of Riemann sum. Itu yang sebenarnya Riemann sumnya lah. Okay. Apa yang kita buat dalam chapter lecture 25 itulah Riemann sum. So if you look at one, maybe you can see one example here. Okay, maybe you can see this example. So we want to evaluate this one. Okay, we want to evaluate this one. So this is x cubed dx. So we want to evaluate it from -1 until 2. So because you all know that -1 is your A, so this is your A and this is your B. So you can find the delta xi as 2 minus -1 over n, which is 3 over n. So for n2, you just let it as n, okay? Because as we can see that more rectangles or the higher n, meaning the higher accuracy. So we just let it go at first. Okay, kita biarkan je. So dalam Riemann sum kita nak letakkan n ni sebagai infinity. Because we want to get very close to the actual value. So tu kita letakkan n ni dalam sebagai infinity here. So we just let it n as it be. Kita letakkan n saja dulu. So our x0 will be -1, s1 will be here, x2 this one, and si will be this one. So if we want to compute the area under the curve using Riemann sum, okay, this one using Riemann sum method, we have to compute the limit of what is this one? This one is s cube tadi, function ni tadi, okay, s cube tadi. But for now, the summation of s cube times delta xi, which is 3 over n. Okay, so this summation lah. from when I equals to 1 until n. Until n. Untuk summation dalam ni. But kita nak cari dia punya limit when n approaches infinity. Okay. Maksudnya apa? Kita nak cari limit when n approaches infinity for the summation of xi cube times 3 over n. When n equals to 1 until, when I equals to 1 until n. So, for this one, xi, okay, macam mana kita masukkan xi ke dalam function. So, kita masukkan negative 1, ni xi ni, kita jadikan dia, kan kita tahu xi ni ialah macam ni. So, kita gantikanlah ke dalam ni, kita akan dapat macam ni, bentuk ni. Okay. So, that's when we have to do the summation tadi. Okay, kita pecahkan dia. Kita boleh pecahkan. We can divide our function here to become like this one. Okay, so jadi macam ni. Because it is cube just now. So remember again yang tadi tu. Mana? This one. Okay, because it is cube. So it will be like this one. Okay. So you can see that we have to compute the summation of I square and we have to compute the summation of I cube. All right. Okay, how to get this one? We have to expand it. Maksudnya kita kena buat pengiraan. Negative 1 plus 3in. We have to compute this one. Okay. So that's how we get yang ni lah. Okay. That's how we get this one. So by using the formula of summation just now, we will get this one, and we can simplify it. And because this one goes to infinity, so this one will be 0, 0, 0, 0. And then you simplify, you will get finally, you can simplify it to this one, and finally you have 15 over 4. Okay, you have 15 over 4. Okay, why this one ada negative 3? Why this one has a negative 3? Why this one has a negative value here? Because this one is actually represent the area under the curve under the x-axis here. Okay, sebab tu kita ada negatif 3 kat sini. Dekat jawapan tadi kan, ada negatif 3. Because actually the negative 3 actually represents the area under the curve for this region. Okay, for this region. So maybe in the final, maybe they ask you how to compute the area under the curve. Maybe they can ask you to use the integration technique. I mean the usual one, or maybe they can ask you to use the Riemann sum. Okay, so that's why it's very important to relate the concept of Riemann sum with the concept of the integration or antiderivative. So that one is the Riemann sum. Okay, next. That one is the Riemann sum. Okay, so this is the properties of a finite integral. Okay, I think the finite integral also has been tested in your quiz, right? In your last quiz, but it doesn't mean that it cannot come out in the exam lah. Okay.
Doktor,
Yeah.
doktor tak record lagi.
Saya rasa yang ni sebab kita just tak ada apa-apa, kita tak masuk syllabus pun, so saya memang tak record lah. Okay.
Okay, doktor.
Next. For example, this one is a finite integral. Okay, we can find the area of the region bounded by the curve. For example, like this one, sin x over 0 and 2 pi. Okay, so this is the region of under the curve. So we have, kalau macam ni contohnya, we have to find two area under the curve, region A and region B. So for this one, for example, you can see that for region A, how to compute the region A will be for the sin x from 0 until pi, and for the B from pi until 2 pi. Okay, from and 2 pi. So this one you can see lah macam mana nak buat. So that one is a finite integral. You can find some examples in the internet how to compute the area under the curve if we have two functions. Okay, for example, we have two functions. Sebagai contohnya, if we have y and x, so we have, for example, y equals to x, so we have this function y equals to x. So this is fx, and we have gx. For example, gx equals to maybe x squared plus 1. Okay. If you use this rule, this is x, right? And maybe this one is x squared plus maybe 4, or maybe 4 kita boleh minus 5, for example. So maybe they can ask you what is the area of this region, for example. So you must know how to compute it. Okay, kamu kena tengoklah macam mana nak compute region macam ni, sebagai contoh. Okay. That one is the finite integral. Next, maybe before L'Hopital rule, maybe we can not this one. This one. Can maybe. Oh, I think exponential. Oh, this one. So, yang tu tadi chapter 5 lah. Okay, chapter 5. And then we have also the logarithmic. Okay, before that, the rules of derivative, for example, of course, you have been asked about the derivative in the test 2, but the rule, for example, the reciprocal rule, the division rule, the product rule of the derivative is very important anywhere. Okay, it's very important anywhere. Maksudnya anywhere tu maksudnya bila kamu buat any computation using the derivative, maybe you have to use the product rule, or maybe you have to use the division rule, or maybe you have to, okay, yang tu memang saya tak pernah cakap lah dia punya kepentingan, the importance of the rules. Okay, next, okay, chapter 6. Chapter 6, logarithmic and exponential functions. So we have also covered this one, the logarithmic. Okay, so this is the natural logarithm function. Okay, how we can get this one? How we can get nx as this one? Okay, maybe that one, maybe you can read again how to get that one. And then how the graph of the ln and its differentiation of the natural logarithm, and of course the antiderivative of the natural logarithm. Okay, and of course for the exponential function also lah. Okay, untuk exponential function, kita tahu dia adalah inverse function of the natural logarithm. So that one also, maybe you can read by that. Then, okay, this one, the L'Hopital rule. Okay, the L'Hopital rule, we see that differentiation can be used to evaluate limits under the circumstances. Okay, this meaning that the L'Hopital rule is also an application of derivative or differentiation. Okay, kita boleh gunakan differentiation or derivative dalam L'Hopital rule. The use of exponential function and logarithmic function also aids in the process. Kita juga boleh disebabkan itu juga disebabkan kita gunakan differentiation to evaluate limit under circumstances. So the differentiation of exponential and differentiation of logarithmic function can help us in the process of computing a function in the circumstances. Okay, we will discuss limit form and introduce a systematic method called L'Hopital rule. For example, okay, yang ni, we know that if we have infinity plus infinity will be infinity, infinity times infinity will be infinity, and so on. And this is what we call as the undefined or indeterminate form. Okay, kita tak boleh nak cari nilai dia. Indeterminate. How we can find a value of 0 over 0 or infinity over infinity or 0 times infinity? Okay, we cannot determine the value. But that doesn't mean that it doesn't have a value. Okay, it doesn't mean that it doesn't have a value. That's why we can use the L'Hopital rule to evaluate the value. So for example, this one, the L'Hopital rule of 0 over 0. So let function f and g differentiable in the interval cb with g and g prime non-zero in cb, such that the limit of fx equals to the limit of gx when x approaches c from the right side, the limit will equal to 0. Ataupun then the limit of fx over gx will be equals to the limit of f prime x over g prime x. That one is 0 over 0. So for the L'Hopital infinity over infinity, we can also have the same condition. We can also have the same result. We can also have the same result. But this one for when the limit goes to infinity. So maybe we can look at some examples untuk L'Hopital rule again. Maybe yang ni. Okay. So for example, the limit of ln x over square root x. Okay, kalau kita, if we evaluate the limit directly, we can see that the limit will be infinity over infinity, because the ln infinity is infinity and the square root of infinity is infinity. So meaning that this one is in the indeterminate form. Kita tak boleh nak cari dia punya value. So we have to use the L'Hopital rule to evaluate the value of the limit. So by using the L'Hopital rule, we differentiate this one. Okay, we differentiate log x, and then we also differentiate square root x. So we know that by using the exponential function, by using the derivative of the logarithm function yang kita dah belajar dalam chapter 6 tadi, that's why I say that the importance of knowing the derivative of logarithm function, exponential function, and so on. So by knowing the derivative of logarithm function, we know that the derivative will be 1 over x. And then the derivative of square root x will be 1 over 2 square root x here, macam ni. So if we simplify it, we will get 2 over square root x. So if we simplify this one, kita akan nampak dia dapat, if we substitute x here to infinity, we know that this one will be equals to 0. Okay? 2 over infinity is not 2 over infinity is not indeterminate form. Okay? 2 over infinity ni bukan. Infinity over infinity, yes. 0 over 0, yes. 2 infinity over infinity, yes. That one is the indeterminate form. But 2 over infinity, not indeterminate form. Maksudnya kita boleh cari nilai 2 over infinity, which is 0. Meaning that we have successfully using L'Hopital rule to find the limit of this function. Also, we can also use it by using the rational function. Okay, kita boleh juga dapatkan limit untuk rational function menggunakan L'Hopital rule. For example, this one. So if we try to compute this one, we still cannot. Okay, kalau kita substitute the value of x with infinity, we get infinity over infinity. So meaning that we use L'Hopital rule, we find the derivative of the numerator and derivative of denominator, we get this one. If we substitute again, still infinity over infinity, so still indeterminate. So using again L'Hopital rule for the second time, we get 6 over 14. 6 over 14 is determinate form. Maksudnya memang ada nilai 6 over 14, which is equals to 3 over 7. Okay, this one, exponential function. Okay, so you can see here, if x goes to 0, you will get 1 over 0 minus of 1 over 0, which is infinity minus infinity. This one is also indeterminate form. Jangan pula dalam exam, if infinity minus infinity, you put 0. Salah, Salah. So, okay, this one, they try to rewrite it in a different way, but still, you get 0 over 0. So, still indeterminate. Then they try to find the derivative of this one and this one by using the L'Hopital rule. Okay, kat sini barulah masuk L'Hopital rule. Kita akan dapat macam ni. But still, 0 over 0. So, you use L'Hopital rule for the second time. Maksudnya L'Hopital rule ni boleh digunakan berkali-kali. Maksudnya boleh iterate lah, boleh buat iteration. Boleh buat first layer, second layer, third layer. Dia boleh buat macam tu. So you can use the L'Hopital rule for the second time. Okay, when they use the L'Hopital rule for the second time, meaning that they find the derivative of this one and the derivative of this one. So you get this one. And then when they try to compute, they get negative 1 over 2. Okay, negative 1 over 2. So, dah dapat negative 1 over 2, finish lah. Dah dapat suatu nilai yang kita boleh kira, boleh hitung, which is negative 1 over 2. So that one is a L'Hopital rule. Okay. Of course, the L'Hopital rule is a very important tool, especially when you are playing with the infinity. Okay. So because it is important rule, maybe yalah, bolehlah disoal dalam your English final. Alright. Then rational function. This is of course the technique of integration. Oh, of course the integration by part. Okay, I forgot to put here. Maybe you can read again integration by part also, and of course the this one rational function. So how to integrate the rational function? There are certain ways or certain techniques that you can use to integrate the rational function. So the first technique or the first type of rational function, you can transform it to the distinct linear factor, and the second type is a repeated linear factor, and the irreducible quadratic factor, and also the repeated irreducible quadratic factor. I think we have covered this in the last 2 weeks. So the first thing that you can try to do for rational function is you are using long division. Okay, long division. Mungkin boleh letak contoh sikit long division. I can put one example of the long division. Maybe x cubed plus x squared minus x plus 1. Hey. Okay. So meaning that macam ni lah. Okay, x cubed plus x squared minus x plus 1. X square minus 2 lah contoh. Okay, so if we want to compute this one, okay, we want to simplify, to rewrite it in the another form. Okay, so how to do the long division? So this one will be x. Why? Because x square times x will be x cube. Okay. Kalau contohnya kat sini 3x square, 3x cube for example. So we put 3x because x square times 3x will be 3x cube. Because our aim here, we want to eliminate this 3x cube. Okay, so for this one is negative 6x square. And then this one tak ada, so kita biar je. Okay, so it will be like this one. So x square plus 6x square will be 7x square. This one negative plus 1. And then x square and 7x square. We want to eliminate this one. So will be 7x square. Sorry, plus. Okay, plus. So this one will be 7x square. And this one will be negative 14x. Okay. So this one, negative x plus 14x will be 13x. Yang ni patut mana ada x. I think I have a mistake here. Sorry. 7x square. Negative 14. This one is negative. Oh, I think. Sorry sebab tak berapa sihat ni. Kalau betul sihat memang semua benda tak jadi. So, okay, x square. So this one will be negative 6x. And then this one is 0 lah. Is 0. Okay. So x square negative x plus 6x will be 5x. This one is 1. Okay. So this one will be 1 because x square times 1 is x square. This one negative 2 times 1, negative 2. And this one is 0x. So you don't have to, all right? So this one will be 5x 1 plus 3. Okay. So this one you can rewrite it as 3x plus 1 plus 5x over 3 over x square minus 2. All right. So that is the long division. And then the distinct linear factors. Okay, of course you can check again. You can do some exercise on the long division if you are not confident enough to execute the long division. So if we have a rational function, we can rewrite it to the distinct linear factor. Okay, for example, this one. So how to know which technique we can use? Okay, ataupun how to determine the type of a rational function. Sebab kita ada 4 tadi kan. So if we are given a rational function, how we can identify whether this one is distinct linear factor or repeated linear factor or this one or this one. How to determine? We have to observe the denominator. Okay. So for example, this one, the punya denominator can be rewrite to this form. So this form is actually distinct linear factor. So macam tu kita nak tahu sama ada kita punya rational function ni distinct linear factor ke, repeated linear factor ke, or what. Okay. So if we have like this one, we can rewrite it as this one. Okay, kita akan bagikan kepada 3 different fractions. A over s minus 1, B over s plus 1, and C over x plus 3. Okay, so to find A, B, and C, so to find A will be A because we have to multiply it with the denominator of other fraction. Okay, kita kena darabkan dengan denominator untuk fraction yang lain. Sebagai contoh, A kita darab dengan x plus 1 dengan x plus 3. B we multiply with x minus 1 and x plus 3, while C we multiply it with x minus 1 and x plus 1. So we will get this one, which is actually equals to this one. Okay, they equal. So meaning that you can see that this one, okay, if we try to simplify it, kalau kita expand this one, we will get x square plus 4x plus 3, and then is x square This one is plus 2x minus 3. And this one is minus 1. Right? So, meaning that for for x square, dia ada dalam A, ada dekat B, ada dekat C. So, meaning that for the x square, we can factor out x square to get A plus B plus C. Okay? S square. And for S1, S square here is 1. 1 S square. Meaning that A plus B plus C equals to 1. Okay, so ini 1. And then for X, untuk yang ada X, this one A is 4A. 4A X and then 2BX. So for A plus 2B X. And then for the coefficient X is 4. Meaning that for A plus 2B equals to 4. And then for the integer part, this one is 3. 3A. 3A minus 3B minus 1C. So we have this one, which is equals to 1. Meaning that we can have 3A minus 3B minus C equals to 1. So we will have 3 variable of 3 equation. 3 unknown of 3 equation, meaning that we can solve that one. Okay, kalau kita cari, if we solve this one, okay, if you solve this one, you get A equals to 3 over 4, B equals 1 over 2, C equals to negative 1 over 4. Of course, if they are asked you in this kind of question in the final, you must find the equation. You must show how you get A, B, and C. Maksudnya kamu kena buat persamaan serentak. Okay, you must solve the simultaneous equations to get A, B, and C. So you will get this one, and then you can integrate it. So if you integrate to these 3 different fractions, you will get like this one. So that one is the distinct linear factor. And we can also have a repeated linear factor. Okay, we can also have a repeated linear factor. So again, how to know whether it is a distinct linear factor or repeated linear factor or irreducible quadratic factor? You observe the denominator. Kita tengok denominator tu macam mana bentuk dia. So for example, this one. Okay, this one you can see that one of our numerator here, okay, is x plus 1 square. Meaning that is repeated. Sebab dia square, dia repeated. Kalau dia cube, still dia repeated juga. So for the repeated, you must rewrite it as this one. However, for this one, okay, be very careful. So for this one, for A1 to A1, kamu hanya perlu, you have only to multiply with x minus 3. Why? Because this one is already include x plus 1 of a power 1. Okay, sebab the power 2, so dia dah include sekali power 1. So you don't have to multiply it with x plus 1 juga. Okay, you only have to multiply with x minus 3. But for A2, you have multiplied to this one and to this one. Okay, because the tip is actually you want to find back. You want to find back this one. Okay, you want to find back this one. So meaning that if they have x plus 1, so how can x plus 1 can get to this one? Meaning that x plus 1 must multiply with x plus 1 and x minus 3. X minus 3. I think this one salah ni. I dah betulkan hari tu kan? Okay, x minus 3. Okay. apa yang boleh menyebabkan x plus 1 ni jadi macam ni balik. Itu kita boleh tahu dia punya numerator ni nak darab dengan apa. Okay. Sebagai contoh, x minus 3, how can x minus 3 can obtain this form? So x minus 3 must multiply with x plus 1 square. Baru kita dapat, that's why A3 times x plus 1 square. Okay, kita akan dapat macam ni. So if you have that one, you can expand lah. Okay, for example, this one tak payah nak expand lagi. So this one is x square berapa? 2x minus 3. And this one is A3 x square plus 2x plus 1. Right? Okay, kalau ni nak tulis balik pun boleh, tak masalah. So for the x square, which coefficient have an x square? A2 and A3 only. Okay, so A2 is 1A2 plus 1A3. Okay, so for the x square, A2 plus A3. And then what is the coefficient for x square here? On the left hand side is 5. Maksudnya A2 tambah A3 sama dengan 5. That one is the first equation. And then for the x, A1, this one is negative 2A2, 2A3. And what is the coefficient here? For x is 21. So 21x equals to this one. Meaning that A1 minus 2A2 plus 2A3 equals to 31, which is the second equation here. And then for this one, if negative 3A1, negative 3A2 plus A3, which is equals to 4. Meaning that for our third simultaneous equation is negative 3A1 minus 3A2 plus A3 equals to 4. This is the third equation. So you solve this simultaneous equation of 1, 2, and 3. You get the value of A1, A2, and A3. So macam ni lah sebenarnya. Okay, kita tunjukkan dah. So you solve this one. You get A1 equals to 3, A2 equals to 2, A3 equals to 7. You have this one. And you can find the integration of these three fractions. Right? So for the S yang ada square tadi tu, you don't have to use the ln, the antiderivative of the ln function lah. Okay? Sorry, the antiderivative of this one lah yang menyebabkan menghasilkan ln function ni. Okay, that one is for the repeated linear factor. Okay, this one for the irreducible quadratic factor. So again, you look at your denominator. How can you, what kind of form that your denominator can get into? So for this one, actually this one is cube, meaning that you have to reduce it to the quadratic and linear factor. Okay, kamu kena cari suatu cara untuk tukarkan cubic function ni, S cube, cubic function, to quadratic and linear function. And then for this one, okay, dia sedikit berbeza dengan linear factor. For the quadratic function, for the quadratic factor, the numerator you must put bx plus c. Dia ada x kat sini. Bx plus c. Okay, because the power, okay, the power here, okay, if your denominator is linear, ini linear, x kuasa 1 linear, so the numerator must be constant. But if your denominator is quadratic, meaning that the numerator must be linear, kuasa 1. Okay, dia macam tu. Okay, dia macam tu. So this one, so for this one, for the s square plus x plus 1, for the a, you times with this one, while for the b x plus c, you times with this one. So you expand it, you buat macam tadi, you akan dapat a plus b equals to 3, a minus b plus c equals to 2, a minus c equals to negative 2. And you get a, b, and c, the value of it. Okay, so that one is the irreducible quadratic factor. And you can see for the repeated irreducible quadratic factor yourself, okay? So that one is the technique, one of the popular technique of integration. Next, the partial derivative. We have covered this last week. So this one is very important for you when you want to evaluate the derivative of more than 2 variables. Okay, so function over several variables, we call it. So partial derivative. So for the partial derivative, so again, this is how you can compute it of a partial derivative. So if you want to compute the partial derivative of fx, so we need to treat y as a constant. So we derive fxy with respect to x. And on the other side, if we want to compute the partial derivative of y, we treat x as a constant, and then we derive fxy with respect to y. So if you have 3 derivatives, for example, we have z, we treat x and y. Sorry, kalau kita ada function x, y, z. So we treat, dan kita nak cari partial derivative of fz. So we treat x and y as a constant, and then derive f x, y, z with respect to z. Kalau ada 3 lah. Okay, kalau ada 3. So that is partial derivative. And of course, the partial derivative have several notations that you can use. And this is how the partial derivative according to the limit of to the definition of derivative using the concept of limit. And we can also have the higher order of partial derivative. So for example, we want to compute this one. Okay, we have this function of 2 variables, x and y. and we want to compute the partial derivative of X. Okay, so if we are using, kalau kita gunakan definition of partial derivative, kita kena guna macam ni lah. Okay, so bergantung. It depends on the question, what the question wants. If the question doesn't state that you have to use the definition of partial derivative, you can straight away evaluate it without using this method lah. But if the question asks you to find the partial derivative using the definition of partial derivative, you must use the concept of limit here. Okay, yang macam ni. So kalau dia tak suruh, kamu straight away pakai macam ni. Okay, straight away use this method. For example, they want you to find the partial derivative of y, meaning that we have to treat x as a constant, and then okay, ni ada x, y, z. So you must treat x and z as a constant, and then you derive the function, this function with respect to x. Okay. So I think because we have just recently covered this, we don't need to go again lah. Okay, so that's all lah. Okay, itulah yang boleh saya katakan the things that maybe you can focus during for your final. Okay. Okay, any question? Ada soalan? Okay, okay, kalau tak ada soalan, sorry I'm kind of having a very big headache juga. Okay, regarding your carrying marks, okay, I will try to sum up your carrying marks within this week. Okay, saya akan cuba compute kamu punya, tolong kirakan kamu punya carrying marks for this week. This one meaning that this one including your tutorials, your SCL, your quiz, and of course your result for test 1 and test 2. So for those who still not submit their tutorials, please do so. I think by this week lah. Okay, before Thursday. Okay, sorry, not before Thursday. Before Wednesday or before Tuesday. Okay, I really need before Tuesday because I want to sum them up. Okay, so siapa yang masih ada lagi tertinggal tutorial yang tak hantar tu, please do so before Tuesday or paling lambat Tuesday before Wednesday. Okay, because I think the lecturers have to submit the carrying marks before or on Thursday, hari Khamis. So Rabu tu memang saya kena kira semua. So after that, maybe you can know your carrying marks. So for those who think that they have a quite high carrying marks, maybe you can have peace of mind sikit lah. Okay, maybe bukanlah saya suruh awak relax. Jangan relax pula kalau ada carrying mark tinggi. I mean that you can have a peace of mind. Boleh lega sikit lah. Okay, but for those who have a low carrying marks, please be very prepared for your final because your final carry 40 marks more. Okay, kalau kamu ingat balik test 1 20%, test 2 20%, and then we call it as a continuous learning CL, we call it as CL 20%. So this one is 60%. So your final and the remaining 40%. So I will try to compute the 60% for you. so that before you go into your final, you will know how much, how many marks over 60% that you get. Okay. Okay. Any other question? Okay. Kalau tak ada soalan, maybe I can finish early. Okay. I'm so sorry because I'm not feeling very well. I tak tahu bangun pagi tadi bangun kepala pening. Okay, maybe we can take a picture for our last class. Okay. Ya, okay, boleh buka kamera masing-masing lah. Cepat dia.